Now we will discuss about another important feature, that is the diagonal relationship. So the diagonal relationship signifies the similarities in properties of the elements of the second period with the respective diagonally opposite third period elements. So if you see the second period element lithium, beryllium, boron and carbon, and if you see the third period element sodium, magnesium, aluminum and silicon, so you will observe that the properties of lithium and magnesium, this pair, is kind of similar, whereas the properties of beryllium and aluminum, that is also similar, and the properties of boron is also very close to the properties of silicon. Now why this happens? So to understand this, the thing is, most of the periodic trends that increases from left to right, that actually decreases from top to down along the group. So if a trend is there that is increasing this way, that will also decrease this way. Or if you go this way also, the trend decrease this way, whereas increase this way. So that is how it is. These diagonal elements are actually having almost same properties. Now I will try to justify it by giving some arbitrary calculations. For example, let's take this beryllium and aluminum, or boron and silicon. Let's take this boron and silicon, okay? And let's consider this atomic radius and metallic character. So, for example, boron, let's consider the atomic radius and metallic character is denoted by x. And we know that atomic radius decreases along the period. So, if we go from here to here, the atomic radius will decrease, right? So, this atomic radius and metallic character I denote by x, it will decrease. Let's suppose it will decrease by 1 unit. So, here in case of carbon, it will be actually x minus 1. And again, suppose in case of going down a group from boron to aluminum, this atomic radius and metallic character increases by 1 unit. So from boron to aluminum, it will come down and it will become x plus 1, because we are defining that from top to down, it gets increased by 1 unit. Okay. Now, if you go from aluminum to silicon, again, the atomic radius and metallic character should go down or should decrease by 1 unit, because we have already defined that it will decrease by 1 unit from left to right and it will increase by 1 unit from top to down. So if we go from aluminum to silicon, it will again decrease by 1 unit and it will be x plus 1 minus 1. So ultimately, we will find the value x. Same thing we can do from carbon to silicon, and if you go carbon to silicon, so in case of carbon, the values of atomic radius and metallic character were x minus 1, and from going top to down, we are actually increasing the value by plus 1 unit. So again, it will be x minus 1 plus 1. So it will come as x. Now, if we compare the values of boron and silicon, we see it comes nearly same, x, both are x. So that's why if we see the diagonal relationship, if we go diagonally in the periodic table, we find out that most of the properties are very close to each other. And yeah, this works in the lower atomic weight, low atomic number molecules. Okay. So this, we have seen atomic radius and metallic character, which decreases along the period from left to right and increases along the group from top to bottom, right? Now let's just clear it. And let's see the trend of ionization energy, electron affinity and electronegativity. Okay. So these things, what happens if we consider it as to be, if it is a y, and we consider that it increases by plus 1 unit. From left to right, it increases by plus 1 unit, and from top to down, it decreases by 1 unit. Okay. Now we will take this pair, beryllium, magnesium, aluminum and boron. We will take this beryllium and aluminum. Okay. Now let's consider for beryllium, our electron affinity, electronegativity and ionization energy values are y. Now when we go from beryllium to boron, so actually these values will increase by plus 1 unit. So in case of boron, it will be y plus 1. And when we go from top to down, from beryllium to magnesium, these values will be decreased by 1 unit. So it will be y minus 1. Now again, if we go from magnesium to aluminum, we are going along a period. So it should increase by plus 1 unit. So if we increase it by plus 1 unit from magnesium, that means y minus 1 plus 1, and we will get y. Similarly, if we come from boron to aluminum, in boron, these units were, these ionization energy, electron affinity and electronegativity were as y plus 1 unit. Now if we go from top to down, we have to decrease 1 unit. Okay. So we will subtract 1 unit and it will again come as y. So you can see beryllium is also having y unit and aluminum is also having 1 unit. That's why there is a diagonal relationship between this beryllium and aluminum. I hope this method will be easier to understand. So this is a qualitative method. So this is not totally correct. Okay, the values will not be exactly same, but it will be somewhere closer. Now let's see. So all the periodic properties, for example, radius, electron affinity, electronegativity, ionization energy, polarizing power remain more or less same for the diagonal elements of 2p and 3p. In the higher periods, the diagonal relationship cannot be seen due to the presence of d and f electrons. It results so because the group trend of some properties in the transition elements is of opposite nature compared to that in the representative elements. Representative elements mean S block and P block elements. Okay, but the trends along the periods remain almost the same for both d block and representative elements. So if we go to the higher elements, higher atoms, that time this diagonal relationship does not work, because what happens here, we were considering that if we go from left to right, it will increase by +1, and if you go from top to down, it will decrease by -1, right? So this is valid in case of 2p and 3p. But after that, when we have d and f electrons, that time this trend is not valid, because there are some properties in the d block elements that shows opposite trend. Okay, I have already discussed in this at this lecture. You can go back and check. So there are some trends that do not follow the order of representative elements, means S and P block elements. So maybe from along group from top to down, in case of S and P, it is increasing, but in case of D, it is decreasing, or the vice versa. But along the period, it remains same. So along the period, the properties are having same trend, but along the group, the properties may have different trend. So that's why this diagonal relationship is not valid in the higher elements. Now you can see some of the parameters that are given for these pairs: lithium and magnesium, beryllium and aluminium, and boron and silicon. I repeat again, the values will not be exactly same. Okay, the values will be somewhat different, but there will be similarity. It will not be exactly same. Okay. Now you can pause the video and you can look it. My throat is actually hurting. It's a very long lecture, and my throat is paining. I will not go into the details of these similarities in the pair of lithium and magnesium. If you are interested, you can pause the video and you can take a note, or you can read this. So these are for those who wants to learn more. So you can have these informations. Similarities in the pair of lithium and magnesium. Similarly, you can learn about the similarities in the pair of beryllium and aluminium. So if you are interested, you can pause the video and you can read this. I'm not going to discuss in detail. I might discuss these things in some other videos, in some other chapter. And here are some similarities in the pair of boron and silicon. So if you are interested, you can pause the video, you can take a screenshot, and then you can go through this data. Yeah. So there are multiple properties that are similar between these pairs, or the elements which are showing diagonal relationships: lithium, magnesium, beryllium, aluminum, and boron, silicon.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.